In this video, we'll use permute, combina, and combine functions to generate the trendline polynomials of the geometric series using Taylor-Maclaurin series sum and LINEST Polynomial Regression. We begin with the dataset of the geometric series. So this is equal to our formula factorial of k divided by 1 minus x, the quantity 1 minus x, raised to the power the quantity k plus 1, k plus 1, and the value of k. Data validation, list of items 0, 1, 2, 3, and 4. So we have the values of k. So 0, 1, 2, 3, and 4. And we'll chart this. Insert chart. And we will use scatter chart. And use row 1 as header, column A as labels. And the series, that's polynomial, trendline polynomial to the 8th degree. We'll try 10 if that works. No, so we'll just go with the maximum 8 degree. The label, use the equation. The legend, position at the bottom. The vertical axis, the number format will be none. That's the horizontal axis. So we just change the horizontal. Now we go to the vertical axis. We change this. So vertical axis, let's show the axis line. And the number format, you have to change this. So not from the source, we use none. Now we're good. So here we have the trend line and the trendline polynomial of the geometric series. Next, we generate the Taylor-Maclaurin series sum of this series, which is the summation of a times x to the power n minus k, where a comes in three forms: combina, combine, and permute. And the value of n is from k to infinity. So since we don't have infinity, this is 17. So this will be sequence. There are 17, so 17, one column starting from k, incremented by 1. Then enter. So that's k equals 0. At k equals 1, so our n starts from 1 to 17. At k equals 2, our n starts from 2 to 18. At k equals 3, our n starts from 3 to 19, and so on. Next, we continue with the coefficients. So permute A3. So that's our formula, permute n comma k. So this is n comma k. So at n equals 0, n equals 1. That's 1, 2, 3, 4, 5, 6. That's 1, 2, 3, 4, 5. There's an error. 6. Now the error gets bigger. 7. It's very close. And this should be 9. This should be 8. But this is an approximation. We are limited only up to 17. Next, we continue with the combine, the equivalent. So this is equal to our formula, factorial k times combine. combine of n comma k. So n comma k. Then enter. So starting from 0, then k equals 1, k equals 2, and k equals 3. Their values are the same. Next, we use combina. This array formula. Again, factorial k. Factorial k times combina. This time we use combina. Inside combina is n minus k. So n minus k plus 1 comma k. Then enter. Their values are exactly the same. Start from 0, then 1, then 2, 3, and 4. They're all the same. These values are the same. We continue with the series sum. We now complete the series sum. So array formula series sum of the x values raised to the power n minus k. So n minus k starts from 0, incremented by 1, and the coefficient, well, you can use any one of them. We start with the permute. Then enter. There's no equations here. There's no polynomial. So edit the chart, customize, trend line, polynomial, not linear, but polynomial, to the 8th degree. The label, use the equation. Their polynomials are also the same. You'll calculate these polynomials using LINEST Polynomial Regression. So this would be array formula of the x values raised to the power 0 to 8. And calculate the coefficients using LINEST. So LINEST data y and data x. Then enter. Then the expansion. So LINEST data y and data x. Enter. So let's compare. At n equals 0, they are equal. At k equals 1, they're also the same. Let's look at the coefficient. The coefficient of x to the 0, 1. Coefficient of x, 2. Coefficient of x squared, 3. Coefficient of x cubed, 4.01. Coefficient of x to the 4th, 5.01. Coefficient of x to the 5th, 5.61. That's rounded off. X to the 6th, 6.58. X to the 7th, 12. This is 12 rounded off as 12. And 11.9. X to the 8th, 13.3. That's x to the 8. And then x squared. K equals 2. Then the coefficients are the same. And they also match to the polynomial. At k equals 3, you have the same polynomial regression coefficients. There's just an error here. But they're still the same. They are still on the same trend line. Now we try using the combine function. So we change this to combine function. So delete We're now using the combine function. Enter. You still get the same values starting with 0. Yep, 0, 1, 2, and 3. So we're still the same. Suppose I use the combina function. So erase this and we use the combina function. They're still the same. Starting with k equals 0, k equals 1, k equals 2, k equals 3. So this completes the use of the functions permute, combina, combine in the Taylor-Maclaurin series sum expansion of the geometric series and its Linus polynomial regression.